Hello, this is Jacob Westerbeek. This is my ECE 3731 course, Intro to Microprocessors and Embedded Systems. I'm taking this at the University of Michigan Dearborn, and this is my final project, the musical calculator. I wrote the code for this project in Code Warrior, and I'm using the HCS12 Dragonlight board for this project as well. The musical calculator is, simply put, a calculator which takes three inputs, one-digit number and a second one-digit number, and then finally one of the four basic arithmetic operations, either addition, subtraction, multiplication, or division. And it'll, based on the chosen numbers in operation, it'll perform that operation and print the result to the terminal. So, here is my code. Here at the top I have my variables section. I have a few different variables to store numbers in, and then a few different strings to display the terminal for the user. And here, finally, starting in main, I load the stack pointer. I initialize the terminal so we can print to it, and I also set bit 5 of port T as output so we can hear sound coming from the board. So, here we load string 1 and print it. String 1 simply asks the user to enter a number 0 through 9 for the first number. And here, after it does that, we jump to the subroutine get number 1. Here it actually gets the character, and it will check if it's C at any point in the program. If the user presses C, it will reset the program all the way back to the beginning. So if they didn't like a number that they put in or whatnot, it'll reset the program for them. So, so we get the first character. Let's say we put in 1. It'll check if the user put in something that was not 0 through 9. If it was not 0 through 9, it'll jump to try again. It'll simply say, please try again to the user on the terminal, and then it'll loop back to get char. So it'll continue to do that over and over again. If the user doesn't put in a number, it'll keep doing that. Say, please try again, until they finally put in a number. So we finally put in a number. It'll store that number into the variable num1 for use later, and then it'll generate the first sound using a subroutine. The subroutine generates sound 1. All the sounds are two-tone sounds lasting for 1 second, and each tone lasting for half a second in the sound. So here, generate sound 1 happens after we get the first number. The first tone is a frequency of 200 hertz, and the second 500 hertz. So it'll do that for a second from the board, and it'll jump back up to here. It'll jump from this subroutine all the way back up to main. Finally, it will now load the third string, telling the user to put in the second number. It'll print that, and then it'll jump to get number 2. This subroutine right here. This is the same thing as get number 1, just instead it'll store that number into num2 for use later, and then it'll generate sound 2, which is the same thing, just a different sound, different pitch. After that, it'll jump all the way back up to main again. Now it'll print string 4, which tells the user to enter one of the 4 basic arithmetic operations. Print that, and then it will jump to the subroutine get operation. So this is where it gets a little more complicated. All the way down here in get operation, it'll ask the user for a character, wanting them to put in, again, addition, subtraction, multiplication, or division. If it's C, it'll reset the program. So once they put in something, assuming it's one of the 4, it'll jump to the subroutine check operation. So let's say we put in addition first. It'll compare B to the ASCII for the plus sign. It'll see that it is equal to that, so it will not take this branch. So it'll continue down the code, and it'll store that ASCII into operation. So now we know we have the ASCII value for plus in the operation variable. And then it'll continue to the subroutine addition down here. Quite simple. It'll push B so we can use that for later. And then it'll load A with num1. It'll add A with num2, so it'll do the operation plus on the first number and the second number put in by the user, and then it'll store that to num3. Then it will jump down to the print subroutine. Here it will print the operation it performed as well as the output. So it'll load num1, print it, load the operation, print it, load the second number, print it, load the equal sign, print it, and then it will load num3. This I use out to decimal in case the number is greater than 10. So if it isn't greater than 10, it'll still simply put the number out. It'll just have a 0 in front. So it'll be like if 2 plus 2, it'll equal 0, 4. If it is greater than 10, though, greater than 9, it'll print that accordingly. Let me show you that real quick. This one's quite simple. We've used this multiple times in labs before. You see, it'll check if the number is greater than 10, and it'll print it accordingly. So after it out to decimal, it will then return for the subroutine. Unless the number is negative. If the number is negative, it'll branch to down here so it can print the negative sign, and then it'll also twos complement it to then print it out accordingly to the terminal. So, and then it'll return from the subroutine just like before. So it'll return all the way up to here in check operation. It'll continue down the line, seeing that it's not equal to any of these operations, skipping all of them. And then it will skip all the way down here to the subroutine count operation. I use this for in case the user does not put in one of the 4 operations. So, for example, they put in a letter, for example, H. It'll see that they didn't put in one of these 4, and it'll reset the program. But if they did, it will just go through this and not take the branch. It'll just return from it. And see that there's no problems. So it'll return to there, check operation, and then it'll return from check operation up to get operation, and then it will generate the 2 tones lasting for 2 seconds. Those are both right here. And it'll return from the subroutine there all the way back up to main. And from there, it'll go down to get jargon and just wait for the user to press C again so the program can reset. And if they don't press C, it'll just ask again. So let's say we put in negative. It'll come down to this subtraction operation. It's essentially the same thing. Instead of adding num2 to A, it'll sub num2 from A. But again, from here, we have to check if it's a negative number in the print, and then put the negative sign, and then you have to twos complement to get it to print accordingly. You can't just simply print it out like this because it won't print correctly. And then, for example, if we put the multiplication sign, it'll jump to this subroutine, and it will load A with num1, and it will add it'll add num2, and keep looping and adding it until it essentially multiplies the amount of time, or it adds it the amount of times that it needs to multiply it. Very similar with division. Instead, though, it subtracts it, and it'll increment num3, so it'll see how many times the num2 went into num1. And you have to compare accumulator B to accumulator A. So I store accumulator B to the memory location 3000, then compare A to that. So if the numerator is higher than the denominator, it'll finally finish. So it'll count how many times the denominator goes into the numerator. And if they put 0 as the denominator, it will simply print a string that says can't divide by 0, and then reset the program. And here's the check C subroutine. So if it's C, it'll reset. Jump down to reset. It'll clear all these constants, and then say the program has been reset, then go back to main. So that is all the code. I will now demo it to you. Let me pull up TerraTerm. And I will run the program. Alright, so we see the first string here in the terminal. Enter a number from 0 to 9. So I'll put in 2. And the board outputted a sound. Hopefully you can hear it. And then the second number I'll put in 2 again. And then I'll do the addition operation. So 2 plus 2 is 4. Perfect. And then it'll wait for the user to press capital C. I'll press C. Program has been reset. Now let's do, for example, 5 and 2. And we'll do 5 minus 2. Whoops. Sorry, I pressed the wrong button. Program has been reset. So if you mess up, you can it'll easily reset and you can just continue from there. You don't have to close and restart the program. So that's nice. So I do 5 and 2 again. And then minus. 5 minus 2 equals 3. Now let's do a lower number minus a bigger number, so we'll get a negative number as a result and see that that works correctly. So we'll do 3 and 9, and then we'll do minus. 3 minus 9 equals negative 6. Perfect. Reset. Let's do multiplication. Do 5 times, oops, not yet, 5 and 5, and then we'll do times. 5 times 5 equals 25. Perfect. Reset one more time. Let's do 9 divided by, we'll do 3, divide, 9 divided by 3 equals 3. Awesome. It does have a few limitations, though. So, for example, if I do 9 and 2, so 9 divided by 2, it'll only show the amount of times that the denominator goes into the numerator. So 2 goes into 9 4 times. It would have a remainder of 1, though, but it doesn't display that. I have another program that I was working on where it actually does show the remainder, and it works quite nicely. I'll show that at the end quickly. So, also, if you do 7 and 0, and then divide 7, you do 7 divided by 0, cannot divide by 0, program has been reset. You can continue from there. So, it's very nice. Let me do it one more time and hold the microphone up to the board just to ensure that you can hear it well. I'll just do 2 plus 2. So you can hear when you put in the numbers, there's a 2-tone sound, and then when you put in the operation, there's a 4-tone sound. And 2 plus 2 is 4. Perfect. All right. So that is my musical calculator project. So now that the main project is finished, I was working on a little something, and I thought it was kind of interesting. I wanted to see if I could get the division operation to not just show how many times the second number goes into the first number, but I wanted to also print the remainder as well. It wasn't too difficult to do, but it took me a little while thinking and messing around with the code to get it to work just right. So I thought it was pretty cool, and I'd like to show that real quick. So as before in the previous program for the project, if all you could do was divide a larger number by a smaller number, and it would give you how many times that the denominator would go into the numerator. And say, for example, if you did 4 divided by 2, you'd get 2. But if you did 5 divided by 2, it would still give you 2. It would not give you the remainder. But in this case, the program will give you the remainder. Also, if, for example, you put, at the very beginning, you put a larger denominator and a smaller numerator, it'll simply just spit that back out to you, telling you what the fraction is, rather than printing something completely incorrect. So I'll show that off here. Other than that, the program is completely the same. So I'll show off, say, like before, you do 4 divided by 2, you get 2, remainder is 0. But now, whereas before it would not give you the remainder. Now it will. So I do 5, and then 2, and then division, 2, remainder 1. So I thought that was kind of cool to do. Also, for example, if I do 2 and 3, so that's 2 divided by 3, it'll just say the fraction is 2 over 3, 2/3. So, and before I would print out something incorrect if you tried to do that. So I just thought that was interesting to work on. I thought it was kind of fun to do. I'll do another example. So 9 divided by 2 obviously goes into it 4 times with a remainder of 1. There you go. So thought that was cool to work on. Thank you for watching.